Okay, I think that we can start with the first afternoon session. We will have the first talk, but online. Who will and Paris Rivera will be the first presenter. Do we hear Paris? Ah, hello.
Yes, hello.
Yes. Okay.
How are you?
So I think that we can start with the first lecture.
Thank you.
Please share the screen. And the first talk is titled Relationship Between Corn and Bean Yield, Climate Change Indices and Climatic Teleconnection in Guatemala. So we are switching to another continent. And please, Paris, the floor is yours.
Thank you very much. As you say, I have this presentation about the relationship between corn and bean yields, climate change indices or index, and climatic teleconnection in Guatemala. I work in the Research Institute of Engineering, Mathematics, and Physics Science in the Mariano Galvez University. So, for introduction, Guatemala is a country where most of the people live in the rural area, and most of these people are indigenous. And they need the farming to get their basic needs. But now they are facing many problems for the availability and the climate change. This raises important concerns about having enough food and ensuring that the agriculture can continue in the long term. In this study, we will examine how the climate affects the yearly harvest of corn and beans, which are the two principal crops in Guatemala. We will also look at climatic teleconnections, which are links between weather patterns and climate change indicators, as factors that have a crucial role for understand this impact that the climate can make to the agricultures. The target of this study, first, the general, evaluate the influence of the climate in these crops. Specific targets or goals, identify climate teleconnections like Atlantic multidecadal oscillation, tropical North Atlantic index, and others that have possibility influence in these crops. Other target was reduce the data because we have many teleconnections, and we try to make less the data using principal components analysis. Then we try to build multinomial logistic regression models to try to predict how will be in the future the production of these crops in a category variable, high, medium, low. A little context in Guatemala. Guatemala is in Central America. Here is down to Mexico. And we have a influence for the Atlantic oceans. We have the storms, the hurricanes, the tropical waves. In the Pacific, we have the monsoon trough. We have also a little influence of the Madden-Julia oscillation. And also we have influence of the ENSO phenomenon. Guatemala have a diversity of crops, but corn and beans are the principal crops in the culture of the country. For example, in beans, we have 7 types for a color and more of 100 variations of that, similar with the corn. Methodology and data. The data we get from FAO in annual kilogram per hectare. The climate data is from local station in Guatemala, Fourier station in Guatemala, temperatures and precipitation. And we download data from NOAA, and we get this teleconnection like now, AMO, TNA, and others. The period of this study is from 1970 to 2022. We use Earth to calculate the climate change index. We use principal component analysis to try to identify some patterns and relations between the temperature and the crops. And we use correlation analysis to get the same, try to find some relation between variables. Here we can see here the tool Earth Index, and we use here this index, minimum temperature, maximum temperature, intensity, 5 days precipitation accumulation, and others. We can see here, for example, the minimum temperature in Guatemala is increasing in this period. So this is for the climate change, for change the soil and other climate conditions in the country. Here in the left, you can see the comparison between two periods. For example, here we have in blue 1970 to 2000, and in red more actual climate 2001 to 2022, and we can see that the minimum temperature is growing. In precipitation, here we have this index is the amount of 5 days accumulation of rain, and it's growing, but it's not growing than the temperature, but it's growing. And we can see here some years where we have some influence for storms. For example, here in 2020, we have Eta and Iota storms that causes many problems in the region. In 2010, we have Agatha storm, and others like Mitch and others storm that causes many losses in the country. Here we have the comparison too. We can see that in the last years, the precipitation amount in 5 days is growing because these storms, obviously, in the last years. Some preliminary conclusion of that: an increasing number of warm periods, increase in frequency of hot days, increasing maximum 5 days precipitation amount, increase in total annual precipitation a little bit, and decrease in the number of cold days. Then we use this data. I show this very quickly because also only want to show what climate teleconnection we use. Atlantic multidecadal oscillation, tropical Atlantic sea surface temperature, El Niño, quasi-biennial oscillation, El Niño oscillation pattern, solar index, global free air mass index, Arctic oscillation index, North Atlantic oscillation index, and we get this correlation analysis. Here you can see in blue the variables that have positive correlations. For example, here in the blue square, we have these variables that have positive correlation. And for example, this variable, annual mean temperature in 10 percentile, is negative. And this is in Spanish: maíz is corn, and frijol is beans. So this is the first step. We can see some relationships between variables, yields, and some teleconnections. Then we use principal components to try to reduce all the variables, and the principal components result in 10 dimensions, but we can choose only 2 or 3. In this case, we choose only the first 2 dimensions, the first 2 principal components. And for example, here is the value of variance percentage, that is the H value. 38% of the phenomena is explained by the first dimension. But if we added the second dimension, we can get almost the 50% of the phenomena. Here we have the correlation cycle. In this side, we have the positive variables that are relation, and here the negative. In the vertical, you can see the first dimension, 38%, and the horizontal, the second dimensions. The variables that are in the center have a low explanation. So you can discard these variables and only choose the better. Then we want to know what variables are in each component. For example, in the first component, most of the variables are temperature, minimum temperature, maximum temperature, these teleconnections, and other teleconnections. And in the second component, we have most of the rain precipitation, 5 days precipitation, total precipitation per year, intensity, and these teleconnections that are relations with the ENSO. Knowing that, we can make a cluster with the categories that we mentioned in the first slide. And we found some years that have high productions and low productions of these corns. And some of them are related with that teleconnection and other no. So this is not a total explanation of the phenomena, but we found some little relation. Then we make regression models using one variable and the principal components. And we test if these models are okay, are different or not. For example, we use a ANOVA test, and this test says that is no difference if we use principal components or one variable, only one variable. Knowing that, we can start to play with the models, and we use the variables for the future temperature in Guatemala in the last scenarios, the SSP, and we can use, for example, mean temperature, minus temperature, and most of these models present low production of corn and beans or medium after this period. This data, we make another study that have these results for Guatemala in these 4 climate change scenarios. So finally, we have these conclusions. The study, the article is not written yet, so we can receive a recommendation or suggestions. The corn and beans yield show different patterns of sensitivity to the climate. Corn has shown a relationship with a higher temperature, while beans are sensitive to the lower minimum temperature. We identified the importance of the climate teleconnections, for example, the Atlantic multi-decadal oscillation and the tropical North-Atlantic index. Making these models, we can say that the projections shows possible reduction of yields in these crops after the decade 2040. And that's all. Thank you for your attention.
Thank you. So I think now it's time for questions or comments. I'm just wondering, Which plant is more, let's say, sensitive to the climate change? You mentioned both, but which plant will be more effective according to your results?
The beans are more
Beans.
will be maybe more affected, but we can make more models. We are making models with the high temperature, with the minimums, with the first principal component, with the second, and we can see what is these possibilities. But in the first issue, the beans will be low in the future.
Okay. Thank you for your answer and thank you for your presentations.
Okay.
I think that we should go on with next presentation, which will give us Zala Žnidaršić, okay. And she will talk about agroclimatic indices and the impact of climate change on agriculture in Slovenia.
Yes, I will speak in English. So, dear ladies and gentlemen, my name is Zala Žnidaršić, and I come from the University of Ljubljana. And today I will be presenting agroclimatic indexes or indicators and the impact of climate change on agriculture in Slovenia. So recently, changing weather patterns bring extreme weather events such as droughts, heat waves, floods, diseases, frost, and so on, which makes the food system increasingly more vulnerable. To improve the resilience of the system, food supply plays in an important role, especially on a regional level. For that reason, we have been developing agroclimatic indicators to represent the impact of climate change on agriculture, specifically in Slovenia. Such indicators include indicators of frost risk, one of which I will be presenting today, indicators of heat stress and drought, especially agrometeorological drought, of course, extreme rainfall and the impact of extreme rainfall on crops, parasites that impact crop productions, and so on. In this slide, is the sound okay, or is it like, okay. In this slide, there is a summary of the indicators that we have prepared based on the review of scientific literature and based on consultations with experts from various fields of crop production. As you can see in the first table, there are a few examples of the indicators of growing season, and as growing season represents the warmer part of the year, also we will be including indicators of the dormancy period or the dormant season. In those terms, also indicators of parasitoid occurrence. Then another part of indicators will focus on drought and moisture, and another group of indicators will focus on frost. So for the first results that we have prepared, historical climate data has been used for the 30-year period of 1981 to 2010 on a 12-kilometer regular grid. The data was prepared by the Slovenian Environment Agency and is freely available on the OPSI portal online. And this is an example of an indicator of Winkler index, which basically represents growing season for the base temperature of 10 degrees Celsius. Winkler index is specifically important for viticulture, so for wine growers. And on this slide, we can see that during the 30-year period, growing season is prolonging. On the right-hand side, you can see the grid cells moving towards more red, towards the red spectrum of the colors. On the other hand, the temperatures during winter are also increasing. An indicator of this is mean temperature of, this is still the warmest quarter of the year. So as growing season is prolonging, we can also see that, of course, the mean temperature of the warmest quarter of the year is increasing. Also more weather patterns on the right-hand side. And as I wanted to say, we can also notice the shift in winter temperatures as well. So in this slide, I'm presenting the indicator of the mean temperature of the coldest quarter of the year, which is also moving towards warmer colors. The coldest quarter of the year is especially important because of the dormancy period, because the plants need the cold temperatures during the winter to improve their resistance and then continue with the growing season on a healthy start. And of course, we have to take a look at the precipitation data as well. Here I am showing the indicator of effective precipitation. And although the change in effective precipitation isn't the most obvious, notable, we can see a slight decrease in effective precipitation between the two 10-year periods. So especially for the northwestern part of Slovenia in red here. Now I will be presenting an indicator of frost. So frost is for fruit trees. Frost is dangerous for fruit trees, especially when frost events occur after the beginning of the growing season, but especially after bud burst or flowering, depending on the plant. We proposed a new indicator of frost occurrence developed by French researchers for Slovenian data, and we tested with the indicator is presented here. So the probability, the indicator of frost occurrence is represented as the probability that the last frost in the year occurs after the event of flowering or bud burst occurs. We tested the methodology on various varieties of grapevine, apple, and cherry trees grown in Slovenia. We tested this methodology on historical climate data for the 40-year period of 1981 to 2020, and on climate model projections on 6 climate models for the period until the end of the 21st century, and for 2 RCP scenarios, RCP 4.5 and 8.5. And now I will be just presenting a few brief results of this indicator. Here are the results for cherry trees. So the results showed increased probability for frost for the majority of varieties of cherry trees, as well as apple and grapevine trees. Here we can see an increasing probability for frost throughout the century, especially in the case of the RCP 8.5 scenario. The probability is around 40 times greater for the Germersdorf variety, no, 25 times greater, excuse me. And on the right-hand side, I have also written down the increase in probability of frost risk for other cherry tree varieties. The trend is similar in the case of grapevine, although of course results vary from model to model. So with this, here is shown the median and all of the 6 climate models. So some of the models might not show such a drastic increase as the others. But yeah, the median mostly agrees that the frost risk is increasing throughout the 21st century. For grapevine, we calculated up to 60 times greater frost risk for the Riesling variety in the region with subcontinental climate. And for apple tree varieties, the trend is similar to cherry tree and grapevine results, although results, of course, always vary because we are taking account the spread of the models. So currently we are working on agroclimatic indicators as a means to represent the impact of climate change on various aspects of agriculture, and our results will sure be like I forgot the word. With this, I would like to conclude my presentation. Thank you for your attention. Yeah, and some references for the literature review.
Okay, thank you. Do we have some question, comment? Nobody? I'm just wondering, did you test this frost risk on the data, on meteorological data? How do you have frost, for example, as a parameter? Is it like binary 0 or 1, or do you have any information about the frost?
Yeah, the only information that we had was that frost occurred that year. So it's like binary. And this methodology proposes frost like probability, the indicator as a probability for frost risk. So we tested the historical data, how the methodology represented frost risk in the last decades. And it showed that the frost risk in 2010 to 2020 was in fact very high, which was the truth in like observational data, which what the fruit growers observed and on their own scale. And yeah.
Okay, thank you.
Thank you.
If there is no other question or comment, I suggest that we continue with the presentations. And the next one is probably in Croatia. Utjecaj i posljedice meteoroloških ekstrema na šumski ekosustav hrasta lužnjaka. A predavanje će nam održati profesor Damir Barčić.
Dame i gospodo, još jednom vas lijepo pozdravljam. Evo, danas bih ukratko htio prikazati jednu ekstremnu meteorološku pojavu koja ima za posljedicu utjecaj na šumski ekosustav. U ovom konkretnom slučaju na jedan od naših najvrjednijih šumskih ekosustava. Radi se o šumama hrasta lužnjaka, u gospodarskom, ekološkom smislu zasigurno najvrjednije vrste u nizinskom području Hrvatske. Ovdje je prikazan areal te vrste ne samo u Hrvatskoj nego i u Europi, i ono što je bitno na početku naglasiti, zašto je ona toliko bitna, pa najveći dio zapravo drvne zalihe u tom nizinskom području Hrvatske, što se ogleda onda i u ekonomskom smislu, je vezan upravo za šume hrasta lužnjaka. Ovdje vidite na kraju ove tablice preko 48 milijuna kubika je procijenjena drvna zaliha prema podacima šumsko-gospodarske osnove područja Republike Hrvatske. To je standardni podatak, znači izmjera ne samo za državne šume nego i za šume šumoposjednika. U svakom slučaju, zašto su te šume jako vrijedne? Pa ako gledate ovaj prikaz dolje, radi se o godinama tih hrastovih šuma uglavnom, i ono što je najvažnije u ekonomskom smislu je šume koje su najvrijednije su starije od 100 godina, od 100 do 140 godina. Za nas, zapravo za šumarstvo, ključan podatak je i smanjivanje zapravo površine pod šumama. Ovdje sam izdvojio jedan podatak iz povijesnih zapisa još iz polovice 18. stoljeća. Znamo da je šumovitost u Slavoniji bila 70% ili oko 70% prema dostupnim podacima. Danas je ona negdje ispod 30%. Naravno, razloga ima više. Zasigurno neke od prijelomnih godina su sigurno 1848. ukidanjem feudalnih odnosa, i za posljedicu je to imalo u desetljećima kasnije da su šumoposjednici i zemljoposjednici tada ostvarivali najveće prihode upravo od prodaje šuma. Najvrijednijih šuma, a u ovom konkretnom slučaju to se radi o šumama hrasta lužnjaka. I zato vam je ovo razdoblje od 1880. do 1914. doista razdoblje u kojem su se smanjile te površine pod šumama hrasta lužnjaka. Ono što mi danas imamo naravno da je za šumarstvo iznimno bitno i definitivno prema načelima održivosti sa šumskim ekosustavom nastoji se gospodariti ili upravljati prema načelima potrajnosti, a to znači da se potiče prirodna obnova šume tamo gdje je ona naravno moguća, ili ako nije moguća, onda kroz umjetnu obnovu isto tako doći do rezultata da doista u tom jednom dugom vremenskom razdoblju razvoja šume imamo i mladih šuma i srednjodobnih i starih šuma. Veliki problem je nažalost danas nedostatak te prirodne obnove, njezino smanjenje. Zato je i umjetna obnova, koliko god se čini možda taj pojam možda previše udaljen od prirodne, ali u pravilu se radi o tome da se žir ili sjemenski materijal skuplja u šumi i proizvodi u rasadnicima. Pa se onda te sadnice pošumljavaju u šumi i to se radi iz tog razloga jer nemamo dovoljno same mogućnosti prirodne obnove kao što smo imali ranijih desetljeća. Ono što je bitno naglasiti za ovaj šumski ekosustav hrasta lužnjaka je zasigurno taj jedan dugotrajni proces. Naime, nama treba u šumarstvu od mlade šume, od ovoga žira i samoga ponika i pomlatka pa sve do sječive zrelosti ili 140 godina koliko je propisana ophodnja za tu vrstu, punih 140 godina. Znači, to je zakonom predviđeno i na taj način se gospodari već sa tim šumama više od stoljeća. Pokušava se naravno i dalje, ali veliki su problemi doslovno u smislu održavanja te stabilnosti, pojave nekih ekstrema, što ćete vidjeti sad malo kasnije. I naravno sve se to onda reflektira i na stanje tih šuma, koje je do sada barem i prema nekim međunarodnim pokazateljima bilo zadovoljavajuće, vjerujem da je i danas, jer ispunjava sva ona načela vrijednosti u smislu gospodarske valorizacije, ekološke i socijalnih usluga, a to je potvrdila i ova međunarodna organizacija, to je taj međunarodni certifikat FSC koje naše državne šume imaju. Nadalje, naravno ono što je ključno za praćenje i monitoring unutar naših šumskih ekosustava hrasta lužnjaka je sigurno određeni indikatori koji su vezani za klimu i samo bih izdvojio recimo dva dosta bitna u ovom kontekstu, a to je prije svega prosječne godišnje temperature i prosječne godišnje oborine. Naime, kada promatramo unatrag 30 ili više godina naše šume i ono što se događa u njima s obzirom na klimatski parametar, možemo zaključiti, i to je posebno jedna ovako znakovita situacija, da ta srednja godišnja temperatura raste. Nemamo još uvijek potvrđene znanstveno relevantne analize, ali postoje neka istraživanja koja su u tijeku i koja govore da upravo to povećanje srednje godišnje temperature se reflektira na povećani broj šumskih štetnika i na jači, intenzivniji razvoj biljnih bolesti. Sve je to naravno povezano onda i sa tim negativnim utjecajem na taj šumski ekosustav i uopće na taj jedan pojam održivosti i mogućnosti jednog potrajnog gospodarenja. Sami vremenske nepogode ili neki ekstremi koji se događaju, pogađali su i ranije naravno šumske ekosustave i hrasta lužnjaka. Ovdje bih izdvojio jedan koji je znakovit jer je doista radi se i o zaštićenom području, posebno rezervatu šumske vegetacije unutar tog spačvanskog bazena. I jednom nevremenu koje je još 2008. godine zahvatilo to područje. To je bitno jer rezervat je inače Zakonom o zaštiti prirode proglašeno područje gdje je zabranjeno bilo kakvo gospodarenje, znači ili bilo kakva sječa unutar toga područja. Naravno, tu su se vidjele i povećane štete već tada, 2008. godine. Ovdje je i naveden podatak preko 100.000 kubika drvne mase, što je naravno jako velika brojka, ali i te ekološke štete koje su u određenim slučajevima i nemjerljive, isto su tako bile velike. Ono što nekako je ostavilo najviše traga zasigurno je ova godina, ali spomenuo bih prije toga i još 2 godine. Naime, radi se o 1998. godini i 2019. godini. Znakovito je da su se ta velika nevremena ili ti ekstremi dogodili upravo u srpnju. I doista i ove godine 19. srpnja ova fotografija nije iznad Spačvanskog bazena nego iznad Zagreba pred početak tog olujnog nevremena, ali činjenica je da su štete i tada, znači i 98. vidite ovaj podatak o 170.000 kubika drvne mase i 2019. isto tako bile iznimno velike, ali ovo što se dogodilo ove godine jednostavno je nadmašilo sve one neke pesimistične prognoze, jer procjena ukupnih šteta ovdje na karti se vidi koja je zahvatila središnje područje Spačvanskog bazena, upravo one najvrijednije šume prema ovim službenim procjenama državnog poduzeća Hrvatske šume preko 2,5 milijuna kubika drvne mase. To je ogromna brojka i morate znati da je to uglavnom u onim srednjodobnim i najstarijim sastojinama. Znači ono što je najvrijednije u nekom ekološkom smislu gdje gubite drvni sortiment i naravno to se povezuje onda poslije i sa ekološkim štetama jer je smanjena mogućnost prirodne obnove, proizvodnosti staništa. Procjene nekih grubih šteta samo u ekonomskom smislu su oko 200 milijuna eura. Znači to su te grube štete u konkretnom slučaju samo drvnog sortimenta. Ovo je fotografija neposredno nakon same vremenske nepogode. Radi se o snimanju dronom na 120 metara visine. Ova gornja fotografija je georeferencirana, a ova donja je povećana i ovdje vidite doslovno kao čačkalice posložena stabla, uglavnom starija stabla, znači preko 80 godina, 80, 100, 120 godina. Te fotografije doista ne samo da ovako izgledaju katastrofično, nego i u praksi su stvorile ozbiljne probleme. Prvo radi nemogućnosti ulaska u te sastojine. Danas još uvijek i traje na nekim područjima uopće i pokušaj neke sanacije, a pretpostavke su da će sveukupna ta sanacija trajati najmanje 3 do 5 godina. Naravno, to su samo neke procjene, a činjenica je da, evo i ove fotografije sa zemlje snimane, da je šteta toliko ozbiljna bila, da su pojedina stabla doslovno kao prelomljena. Jedna vrlo rijetka pojava jer za područje nizinskih šuma ovakvih situacija i ovakve situacije su doslovno vrlo rijetke. Čak i u nama susjednim zemljama jugoistočne Europe nemamo ovakvih primjera, a pogotovo evo na ovom slučaju to vidite, naime uzdužno raspucavanje debla, što nije karakteristika za tvrde listače, znači za dosta otporna stabla, ali u ovom slučaju to se događalo unutar tog šumskog ekosustava. Procjene brzine vjetra, barem prema nekim neslužbenim podacima za to područje Spačve, su negdje bile oko 180 km na sat, pojedini udari. Nisam siguran koliko je to točno jer anemometar u Gradištu je prelomljen i nažalost daljnje neke brzinu vjetra nije mogao izmjeriti, ali u svakom slučaju ti udari su doista nekako nalikovali i nekim uraganskim udarima i to je nešto što doista je rijetko zabilježeno upravo u ovim našim nizinskim šumskim ekosustavima. Još jedna slika upravo tog zaštićenog područja koje je izuzeto od bilo kakvog gospodarenja i te štete koje i danas imamo posebno u takvim zaštićenim područjima jer s njima se ne gospodari i naravno tamo imate više i starijih stabala pa je onda i šteta još i veća i intenzivnija bila upravo u takvom jednom području. Naravno nisu samo tu bitne ekonomske štete i ta gospodarska vrijednost. Spačvanski bazen je jedan od nama najvrijednijih šumskih kompleksa, inače u cijelom području jugoistočne Europe radi se o jednom od većih kompleksa hrasta lužnjaka na preko 40.000 hektara i on je bitan iz razloga očuvanja i zaštite prirode. Naime, gotovo cijelo to područje je stavljeno unutar Europske ekološke mreže Natura 2000 Imate ovdje izdvojena neka područja koja su i zaštićena temeljem i našeg zakona o zaštiti prirode i doista to područje je zaštićeno i prema direktivi o zaštiti ptica i isto tako prema direktivi o zaštiti vrsta i stanišnih tipova. Znači doista jedno vrijedno ekološko područje koje je nama bitno u smislu održivosti, isto tako i u ekonomskom smislu, jer naravno cijeli taj dio istočne Hrvatske naslanja se većim dijelom na primarne djelatnosti, kako na poljoprivredu, tako i na šumarstvo. Ovdje su, nažalost, gubici dosta veliki. Nažalost, oni se evidentiraju i na opće korisne funkcije šuma, koje su isto određene temeljem pravilnika o uređivanju šuma, pa su to isto određene štete mjerljive, s tim da ti podaci još nisu iznijeti u javnost, pa se o njima tek nagađa kolika će biti problem zapravo što se tiče obnove tih šuma u budućnosti. A naravno, ono što je svima nama u interesu, a posebno šumarskoj struci, a to je da u budućem nekom razdoblju pokušamo nekako što adekvatnije odgovoriti na ovakve ekstreme, iako ako se oni nastave, i to doista ne svakih 10 godina, nego evo sada i nakon 4 godine, zaista smo u ozbiljnim problemima što se tiče nekih kvalitetnih i adekvatnih odgovora, jer naravno radi se o šumama, šumskim ekosustavima koje ne možemo zaštititi kao u recimo poljoprivredi i na taj način smo prepušteni određenim promjenama koje se događaju. Evo, hvala vam lijepa.
Hvala. Evo, hvala i na održavanju tempa. Okay. Now we switch to English and to wildfires. So we will continue with also with extreme events, but we are in Croatia or in Australia?
In Croatia.
In Croatia. Okay. And we will hear something about the split wildfire and initial coupled fire atmosphere simulations.
Okay, this is my
Thank you.
second role today. I will tell you something about the split wildfire and coupled fire atmosphere simulations. I had the opportunity to work with a fantastic group of fire weather researchers from Croatia and Australia. The reason for that was my co-tutel PhD, which was conducted under agreement between two universities, University of Zagreb and Macquarie University in Sydney in Australia, where I spent my first year of the research. Today we have 3 published papers. 1 is under review, 4th and the 5th is ready to be submitted. We plan to publish more, so here I'll present you around 20% briefly of my 20% of my PhD work. Research aims for this part that I'll present you were to reconstruct the wildfire event in order to provide a validation of the model data and to demonstrate that we can run this coupled model for a real event from Croatia. In the end, we wanted to investigate possible fire-atmosphere interactions in this case, which most probably occur, but we didn't have any numerical evidence on that. So just to say something briefly about the split wildfire, we reconstructed it in detail. It's called the mother of all wildfires. That's how firefighting pilots called wildfire, because they could not do anything to contain it in 2017. The wildfire lasted for 9 days. It burned more than 5,000 hectares, most of it in the first 24 hours of the event. More than 1,000 personnel were included in the intervention. Spread rate that we managed to reconstruct was around 35 meters per minute, but the maximum spread rate was up to 55 meters per minute. So you have to run to try to contain the wildfire, carrying all the equipment, which was very, very hard for our firefighters, and they actually could not do anything to contain it in the first 24 hours, which is alarm that something unusually happened, some extreme event, fire weather event, and wildfire did exhibit extreme behavior like spotting, and it had extensive plume, which could be seen all the way to the Italy. even ashes fall 25 kilometers away from the wildfire. Also, there were spotted fire reels, and I accidentally found these photos from one wedding photographer from Split who didn't know what he has in his album. These photos are actually maybe the first professional photos of fire reel in Croatia, and these kind of photos usually circulate the world when this kind of event occur. So it's very interesting to find these photos, because I think these photos have to communicate with Croatian public and with international public what kind of event can happen here in Croatia, not only in Australia, USA or Canada. So this kind of extreme fire event we can also have here, and this is a warning. This is the reconstruction of the wildfire. We took a final fire perimeter from firefighters and divided it into 4 burn periods, named Split 1 to Split 4. X denotes ignition point where the wildfire started. It spread towards southwest. It was carried by a strong northeast wind, but after that, wildfire was in its majority carried to northwest towards Split. This red area on the left represents downslope run of the wildfire. So wildfire ran from the mountain area towards the city suburbs of Split. Yellow area is another downslope run, which is nighttime downslope run towards the city suburbs. And you can see photos. So this is a photo from the Split view. This is where actually fire reels were spotted. This is actually like maybe half an hour before wildfire burned within city suburbs. And this is a nighttime downslope run. You can really see that fire burned in a city along the buildings. And this is 20 kilometers away, photographed 20 kilometers away. You can see how big conflagration is this. And it was impossible to contain it. Luckily, no one died as a direct result of this wildfire. We were very lucky to not have any victims from this wildfire event. So to say something about the coupled fire atmosphere model, in summary, atmospheric part of the model feeds into the fire model. It gives information on a local winds, and local winds are inserted into fire model. And then together with the fuel properties and topography, determines fire rate of spread, fire direction, where fire will go. And then when a fire is burned within the model, it releases energy, and that energy influences then again winds on the lowest levels of the atmosphere. So in the next time step, atmosphere is modified by the energy from a fire. This model requires very important information on fuel and topography. These are domains that we used. In this innermost domain 4, we used fire model. That domain has a 500 meters resolution, which was refined to 33.3 meters. And we used topography on 100 meters resolution, which was again interpolated to 33.3 meters. It's not ideal, we know that, but we got this terrain height, which quietly good represents topography, complex topography of the area. This is the fuel data that we used. We used Corinne database from EU. We converted codes from Corinne database to these 13 categories of fuel, and 14 category is no fuel, which is noted as white color in a map. So each of these 13 categories, they define vegetation type, what kind of vegetation is that, how tall is grass, and how fire would burn within that vegetation, what would be a fire speed and what would be flame height. So all that is incorporated into the model. And now we got these first results of fire. So these 4 lines note 4 burn periods, split 1 to split 4. We ignited the fire where the real fire was ignited. So we ignited that fire grid within the model. The unburnt area in the middle is actually village. So it's a no fuel area. And you can see that that purple line, which is split 1, in that period, fire burned within the model all the way to the coast. The reason for that is most probably coarse input data. That's the first reason. But the second most important reason is that model cannot represent firefighting operations. So, but these results can be interpreted like what will happen if firefighters did not engage with the fire. Okay. So we wanted to simulate this as best as we can, this final burnt area from the real fire. And what we could do, because model cannot represent spotting, which did occur in a split wildfire, but we knew because of detailed reconstruction where the fire was at the time, so we could burn more ignitions into the model. And we did that for 4 more locations. And you can see that with 4 ignitions, we did the model that would represent spotting. We did get this final map that was actually the final fire perimeter. Model does not also have option to stop the fire itself. So we have to decide when is the end. And that was the end of the split 4 burn period. And you can see that at the end of the split 4 burn period, model with these additional ignitions did represent the fire scar well. And about fire-atmosphere interactions. So we use this approach that was used in Australia multiple times, approach to turn on feedback in the model and turn off the feedback. The difference is in inclusion and exclusion of energy that is released from a fire and incorporated into the atmosphere model. So you can see that on the left-hand side, when feedback is on, we have stronger wind speeds. And to look a bit closer, that northwestern part of the fire line, you can see that wind did bend along the fire line. And when we compared this to wind fields only from atmospheric model, and when we compare this to products that we got from feedback of simulation, we could see that wind direction did change and the wind speed did increase. So this is the first numerical evidence of fire-atmosphere interactions along the Adriatic coast. To conclude, we proved with these results that we can use this model for real data from Croatia. Because of the detailed reconstruction beforehand, we were able to validate those results. And the difference between real fire and simulated fire is, as I said, due to coarse input data, because model cannot represent firefighting operations, and because model cannot represent spotting and cannot represent crown fires, which did occur in this event. This research is important for future research, fire weather research, for education purposes, and we believe that sometime in the future we'll be able to incorporate high resolution data. There is high resolution of topography and fuels, so maybe in the future we can also optimize this model for speed, and maybe in the future, I don't know when, we will be able to use this operationally. Thank you.
Thank you, Ivana. Do we have question?
Thank you, Ivana. This is really interesting.
Yes.
You answered, my first question was whether you would be able to use it operationally, but you answered it with the last sentence.
Yes.
But I was wondering, we will have with this new satellite, we have a very good possibility to detect fires, very small wildfires. Is it something that
small?
would very small, below
How small?
below 1 kilometer resolution?
Okay.
And it looks really good. So even small bonfire can be detected in the night.
Okay.
I wonder if this would be additional information that could maybe, in the case of operational use of the model, be possible to use as a, let's say, a spot where the fire starts and then run it from there.
Not sure, maybe one day. Now that I know, Greece is trying first to optimize this model for speed to get results within 6 to 8 hours. That's the last that I heard. Aussies, Australians are still using this model for mainly for research purposes. So this is not still operational, but I don't know, maybe one day. The problem is to have high resolution topography, how to import it into the model. Australia has 7 meters resolution of topography, and for fuel data also 7 meters. So their goal is to get precise simulations, let's say, more precise than detection. They already know where is the fire. So when the fire starts, it's not a problem to start a fire, but maybe sometimes it will be like automatic and then to use these satellites. Yeah, we'll see.
Okay. Thank you, Ivana, once again. And now we switch to the last presentation in this session in Croatia. And Višnja Vučetić will tell us a little bit about the agrometeorološkom mozaiku za mlade.
Evo još jednom vas pozdravljam i drago mi je da vam mogu predstaviti još jedan projekt Agrometeorološki mozaik za mlade, a to je mala škola požarnije šala isto Hrvatskog agrometeorološkog društva. Na tom projektu sudjelovao je veliki broj naših članova i moram napomenuti da smo ovdje spojili iskustvo naših starijih kolege i profesora i članova sa entuzijazmom mladih znanstvenika. Što se tiče male škole požarnije šala, pa predavanje koje smo imali prije u onom prethodnom projektu agrometeorologije u službi korisnika nam je pokazala da ipak sa izobrazbom moramo početi od najranije, od najmlađih, i tako smo mi obuhvatili djecu od 3 do 11 godina. A kako njima to prikazati, pogotovo pojavu šumskih požara, pa najbolji način je u stvari njima je najbliže nešto prikazati crtanim filmom. I zbog toga smo se upustili u jednu, ja bih rekla, avanturu izrade animiranog filma Požarnije šala 2016. godine, a godinu poslije izradili smo i dječji strip Požarnije šala. Damire, da li imaš koji primjerak tu? Pa ja bi isto tako zamolila, isto tako kao što si knjigu pošalji pa da vidite, a oni koji će biti zainteresirani u pauzi si mogu uzeti i taj strip za vašu djecu ili možda unuke. Glavni cilj tog projekta, u stvari male škole, je bilo da problem šumskih požara promatramo sa drugog stanovišta, ne samo sa onog šumarskog i vatrogasnog, nego i sa meteorološkog, ekološkog, pedagoškog pa i humanog stanovišta. Sve sa ciljem kako bi se zaštitio naš krajobraz, zatim mikroklima, biološka raznolikost i geološka isto tako raznolikost. Do sada smo održali 152 male škole u čak 69 mjesta od Dubrovnika duž cijelog Jadrana pa preko Zagreba do Osijeka. Obuhvatili smo oko, točno u stvari, 35 dječjih vrtića, 78 osnovnih i područnih škola i obuhvatili smo negdje oko 7.500 djece i učenika, znači od 3 do 11 godina. Međutim, tamo gdje smo imali i mogućnosti na našim radionicama, pa kao što i danas na ovoj konferenciji, prikazivali smo i film, isto tako upoznali i odrasle, pa negdje 850 do 900 odraslih isto tako vidjelo taj naš film Požar nije šala. Nešto da kažem ko je, osim normalno članova našeg društva, animator filma i ilustrator dječjeg stripa bio je Ivan Šivak, muziku je skladao Marko Juraga, a scenarist i režiser je bio Ivan Đuričić. Moram napomenuti da ponekad je trebalo uskladiti naša znanstvena očekivanja i edukativna očekivanja u stripu, odnosno u animiranom filmu, i uskladiti to sa umjetničkom kreativnošću koju su željeli ostvariti u tom filmu naši animator, odnosno scenarista. A već sam napomenula da je 9 znanstvenika starijih i mlađih sudjelovalo kao konzultanti, suradnici na tom filmu. Njihov popis možete vidjeti dolje. Međutim, moram napomenuti da niti film, niti strip ne bi mogli ostvariti da nismo imali naše donatore, a to je najviše nam pomogla u stvari regionalna i lokalna zajednica Dubrovačko-neretvanske županije, grad, znači Dubrovnik, javna ustanova za upravljanje zaštićenim dijelovima prirode, isto Dubrovačko-neretvanske županije, Splitsko-dalmatinska županija, Primorsko-goranska, Istarska, Ministarstvo znanosti, grad Zagreb. I još uvijek nam i dalje pomažu da bi mogli održavati malu školu, jer morate znati da u Hrvatskoj ima preko 800 dječjih vrtića, isto toliko i osnovnih škola, i tako da je to jedan trajni projekt našeg društva zato što imamo i stalno nove generacije. Prvu predstavljanje, prvu premijeru filma imali smo baš na otoku Lokrumu pokraj Dubrovnika, a drugu u Zagrebu u suradnji sa Hrvatskim društvom novinara. Zatim malu školu smo isto prezentirali na Interliberu u Zagrebu 2017. godine u sklopu znanstvenog kvarta. Ali kao što sam rekla, gdje god smo imali mogućnosti smo i prezentirali, pa mislim da se možda i kolegica Andreja Sušnik sjeća, prvu smo prezentaciju baš imali u Ljubljani 2016. godine, zatim 17. u Budimpešti, u Beču, Novom Sadu i Sidneju 2018. godine. Pojedini članci isto tako su objavljeni o tome, kao i bilo je i na televiziji i na radiju, znači prisutno i u medijima. A kako su sad djeca na sve to reagirala, pa mogu reći da djeca su jako lijepo prihvatila i prvo nakon prikazivanja filma, nakon toga smo imali uvijek razgovor sa njima i oni su uvijek tražili da im još jednom prikažemo ovaj film, a to je značilo ipak da im se jako sviđa. Ali kako su oni reagirali, iz tih svih razgovora s njima mi smo vidjeli da oni jako dobro znaju koji su uzroci požara, ali su ostali jako iznenađeni kad smo im pokazali katastrofalne posljedice nakon požara, da je potrebna dugotrajna obnova šume i da je potrebno isto tako da bi se životinje vratile u svoja prvobitna staništa. A mi smo bili posebno nagrađeni jer znalo se dogoditi da su nam djeca nakon same male škole znali nacrtati nešto i dati ili na satu likovnoga, i to je onda bilo najbolji znak da su oni to lijepo prihvatili. E sad, da malo bude još relaksirajuće na kraju ove naše agrometeorološke i silometeorološke sekcije, ja bi vam da prikažemo vam i film, pa onda možete ići na pauzu i početi dalje sa drugim sekcijama. Hvala lijepa i posebno mi je drago da vas se još u tolikom broju tu odslušalo sve ove 3 sekcije iz agrometeorologije i silvometeorologije. Hvala.
Evo, ja bi s time onda zaključila agro dio ove agro sekcije, kao što je Višnja rekla. Zahvaljujem još jednom svim predavačima. Evo, pozivam vas na coffee break. I also invite all presenters of the next session to bring us presentations. And that's all.